Good evening, I'm Mike Knetter, and welcome to the UW Now live stream, where we bring you experts from the Badger community talking about timely and important topics. Tonight's topic is extreme weather. That was especially timely on our last show last month. You might remember we were talking about Alzheimer's, and our show was disrupted at least twice by tornado sirens. Tonight, we'll be talking about extreme weather, and our show may be disrupted by my forgetfulness. I digress. Tonight, we're going to talk with some well-known weather experts who can help us make sense of what's been going on this summer. Some of the key questions we'll discuss: what are the best metrics to determine trends in severe weather, and what does that data show? Hurricane Beryl, hitting last week, was the earliest Cat 5 hurricane in the Atlantic on record. What can we expect from the hurricane season ahead? And what's driving these trends in severe weather, and what might we expect in the future? Anyone familiar with Wisconsin Public Radio will probably be familiar with our guests tonight. Known as the Weather Guys, Steve Ackerman and Jonathan Martin answer viewer questions monthly about what's happening with our weather, and we've invited them to do the same with us tonight. Steve Ackerman is an emeritus professor of atmospheric and oceanic sciences and former vice chancellor for graduate research and education at UW-Madison. He began his career at UW as a research scientist in the Cooperative Institute for Meteorological Satellite Studies and ultimately led the institute for 18 years. He's an expert in satellite meteorology, which is an area of study that was pioneered right here at UW-Madison. Jonathan Martin is a professor of atmospheric and oceanic sciences and an expert on mid-latitude weather systems, such as snowstorms and severe thunderstorms. He's authored or co-authored more than 40 scientific publications, including the leading undergraduate textbook on atmospheric dynamics, Mid-Latitude Atmospheric Dynamics, a first course. How'd you come up with that title?
I tried to use British understatement, just describe exactly what it was.
Okay. Well, it's good that it's the leading textbook on atmospheric dynamics, even though it's just mid-latitude.
Like that. It should be leading on the mid-latitudes, but you push it as hard as you can, Mike. You know that.
I know. All right. Well, listen, without further ado, I know you guys spend a lot of time together, and I get to spend a lot of time with you as well, which is a great pleasure for me. But I'm going to turn it over to you, and you can kind of set the stage and hopefully prompt some audience engagement and great questions. So take it away, guys.
All right. Steve, I can start with something, and you can.
Yeah, why don't you start? And I missed this. I was out of the state this past couple of storms we just had.
Oh, man. Yeah, that's what I was going to start with. Exactly that.
Yeah.
Boy, I'm coming home from the ball game on Saturday the 13th, and the sky to the north was pitch black at 7:30. And we ended up with the 18th wettest day in Madison's history on that day. 3.3 inches of rain fell in that event on Saturday into the early morning hours of the 14th, Sunday. And so in 85 years of records at the Dane County Airport, this is the 18th wettest day, and pretty remarkable. And in fact, 4.71 inches of rain have fallen since the 13th, because we got another one the day after that was pretty intense as well. And I would say this, that since the 1st of May, we've had 10.2 inches above normal precipitation. And the normal for that period, 1st of May till 15th of July, is 11.7. It's the wettest time of year. So we've nearly had twice the normal amount of rainfall. And that's at the airport. If you're keeping track at home and your home is not the airport, it may well be even more than that, because there's quite a bit of variety when it gets to be this kind of summertime convective weather. So we have had an extraordinary wet period since May 1. And in fact, it goes all the way back really to April 1st. We've only had 5 days as the longest interval since April 1st where we've had no rain at all for 5 straight days, the 14th to the 18th of May. Other than that, we haven't had a streak of 4 days. So that's really remarkable. Persistent and sometimes extremely heavy precipitation.
Yeah, I was out of town, but I do observations for COCORAS, that volunteer observation group, and we live out close to the airport, but we had 3.6 inches on that day, and I was worried about our grass drying out, and then Boom. 3.6 inches. Crazy.
Incredible. And another aspect of this recent, when I say recent, I'm going to continue to refer to May 1st through July 15th of 2024. This period not only has been that much wetter, almost twice as much normal as the normal rainfall during the wettest time of the year, but we've also been 2.5 degrees above normal in temperature. Now, that's a really unusual combination of circumstances, given the fact that there's only been one 5-day stretch without any rain at all. One might imagine, and in the old days, 50 to 60 years ago, it tended to be true that if you had consistently rainy days, they were, as you headed into the middle part of the summer, they tended to be a little bit cooler than average because of the cloud cover and the precipitation. But this time, it's been a combination of both excessive precipitation and warmer than normal temperatures. That's quite unusual. 2.5 degrees above normal since May 1st. So what a weird combination.
Yeah. And that's consistent in general with the longer term as well. Since the 1950s, Wisconsin's about 3 degrees warmer than it was back in the 1950s. And I think now we're getting about our average precipitation, not just summertime, is about 5 inches more than what we were getting back in the 1950s. So
yeah, very interesting. I looked up one other thing today along similar lines. That was the number of days since May 1 through July 15th where we've had at least 1/100th of an inch of precipitation. And we this year have had 32 such days. And more than that, if you include a trace of rain, which is just it rained, but it didn't measure. There wasn't enough to measure. We've had several days like that, probably a dozen or more. But 32 days in the period from May 1st to July 15th where it had at least 100th of an inch of rain. The average for that period, all the way back to 1939 here in Madison, is 27.5 days. So we're a little bit above average in the frequency of measurable precipitation. The record all time was 43 such days in 1993. That's not that long ago. So, 31 years ago, and we had really an extremely wet such period. But then just a few years before that, 1988, everybody probably remembers the extraordinary drought that characterized the summer that year. And in that year, there were only 10 such days, and many of them had, barely more than 100th of an inch of precipitation. So that was a really bone dry year.
What year was that, John, again?
1988 was the dry year.
Yeah.
And the really wet one is 1993.
Yeah, that's when we moved here.
Is that right?
Late 87, we moved here. And 88 was dry as a bone.
Yeah.
And we moved from Fort Collins, Colorado, which is also very dry. But we just thought, what have we done?
And that was one of the warmer summers, too, of the last 50 years, because, that feeds back on itself. If there's no water in the ground, and the ground heats up more when the sun comes up and you get hotter days. So that was characteristic of that period as well. Even in 2012 or 13, we had an extended drought, ended about this time in July. And we might have had 20 days in a row without any precipitation. And remember, the temperatures just around the 4th of July, that particular summer, I can't remember if it's 12 or 13, were at or above 100 for 2 or 3 days in a row. And that was a function of bone dry conditions that really make it tough to get cool. So
there's the map up there showing for Wisconsin how we've warmed since 1950 and how we're definitely wetter as well. Yeah. You have any predictions for the rest of the summer?
I hesitate to do so. I remember we talked on the radio probably at the end of May, because May was already unusual. I think we were 1.4 inches above average for the month of May.
Right.
And I thought, it could turn on a dime and we suddenly could be dry as a bone like we were something like 1988, but that has not happened. Makes me wonder if the conditions are just now set, that even if we get some extended period where the conditions do not exactly promote the production of convective precipitation, there's so much water in the ground, there's going to be a lot of evaporation and thereby probably adding a little bit towards the tendency to continue to be wet. So I guess if I had to make a bet, I'd say we're going to be at least normal for the rest of July and all of August. And that means, in fact, with the water levels the way they are in local rivers and streams, if we get average precipitation the rest of the summer, we're going to push them over the banks because they're already close and some places already spilled over. So it's going to be treacherous if we come out even average for the last half of July and the whole month of August.
Yeah, we live on the mouth of the Yahara as it comes into Lake Mendota. And when we left, the precipitation that we've had prior to us leaving, we had lost probably 30 feet of the bank had come up underwater, and it was just receding. And we just got back today, and all that recession of the water line is now back up again, and everything's underwater again.
Yeah, boy, incredible. We were driving out to Spring Green the other day to see a show, and there were plenty of cornfields out past Middleton and Cross Plains that were not supposed to be puddles. They were not supposed to be lakes. They were supposed to be growing corn, and they had really stunted corn plants because they've been hammered. Those low-level line ones have been hammered since the beginning of May. They just can't get out of the water. And then the recent storms have flooded them. They're not going to get out probably for another week, even if it doesn't rain at all. So
yeah, as you point out, the ground is so wet that when you get this 3.5 inches of rain, it's not going to get absorbed by the ground.
Yeah, there's no place else to absorb it. It's going to run right into streams, rivers, and lakes, and so on. So yeah, it's going to be tenuous at best. Pretty incredible. I looked up too the longest dry stretches. So what's the longest period of time in the summer, June, July, August, or actually May through August, that we haven't had precipitation? In 1988 had the longest such stretch, 40 straight days from the 13th of May to the 21st of June. And not unlike Joe DiMaggio's hitting streak, which ended at 56, but then he started one the next day that went to 17. There were probably other long stretches that summer, but 40 days was the longest. And our 5-day stretch has happened 91 times since 1939. So it's not at all unusual to go 5 straight days without precipitation. I couldn't figure out how to get my data to tell me how unusual is it to have nothing greater than 5 days. So I couldn't finish that project today, but I suspect it's unusual. I suspect that's unusual.
Yeah, I noticed in the comments somebody pointed out that Badfish River, I guess, is 3 times faster than what it normally is right now.
Oh, man, that's
probably associated with the same type of weather that we're dealing with. Yeah. And some think it's been I think it says there that it's been a gorgeous weather in the Dead River Basin of Marquette. But I don't know. My favorite weather is in summertime. My favorite weather tends to be fall. A little drier, less humid.
Fall's nice, but nothing beats the winter when it really revs up. But I agree with you.
Yeah, you're a snow guy.
Yeah. This summer we got the mosquito vying to be the state bird, given all these early spring and early summer rains. So it's kind of like in Minnesota. So it's kind of bad news that way. If you live anywhere near standing water, it must be the worst summer in many years. In fact,
it wasn't so bad in May. It's just this last couple of weeks seems to be like they've really come out.
Well, and remember that time we were at the radio show, Phil Pelletieri, who was the entomologist, I think he's now retired at UW. He told us there were 22 different species of mosquitoes that hatch in serial fashion. So if you don't have a bad May, that doesn't mean anything about June, July, or August, because there's different species involved. Those things are relentless. They're the greatest threat to human life ever on the planet. I just read a book about that. More people have died because of mosquitoes than anything else. Isn't that unbelievable?
Wait. So because of mosquitoes, because they transmit diseases.
Yep, that's right.
Yeah.
Yep. Incredible.
Yeah, we thought COVID was bad.
Rightly, given what's been happening locally, we've talked a lot about local weather. And you focused mainly on temperature and precipitation. But of course, there are other ways to measure what's going on, around us, whether it's humidity or barometric pressure or et cetera. And I always wonder, we can count the number of hurricanes, we can count the number of tornadoes, we know, different categories of hurricane, different categories of tornado, severe convective storms, kind of violent thunderstorms with high straight line winds. I mean, how do you categorize the increase in severity or frequency of storms generally, and what is the evidence on that? In the continental United States?
Yeah, this Storm Prediction Center, which is part of the Severe Storms Lab in Norman, Oklahoma, takes careful count of a series of categories that have to do with severe convective weather. This is a really good question. One of them is wind speeds, straight line wind speeds and gusts. So that any storm that has a gust over 50 miles per hour, I think, gets registered as a storm with that gust. And so we can count those. Also, hail sizes are registered in a systematic way. And then what's the other one, Steve? I know I'm thinking about that map, the SPC map, the severe weather report map. There's hail reports, there's tornado reports, and they come in variety categories. And then there's the winds. Yeah, I can't think if there's another one or not. Maybe those are the three. So those are systematically counted not only for number but also distribution. Where are they happening? And it turns out that in the last, I think, 30 to 50 years, this is work by Victor Gensini down at Northern Illinois and some other colleagues. Tornado Alley has moved eastward from where it used to be. It used to traditionally hit the middle of Oklahoma, the panhandle of Texas, and into southern Kansas, and maybe into even southern Nebraska. It's moved a little bit eastward. Partly, some of the scientists themselves are saying partly because the population's expanded and more storms, tornadoes now in this case only, have been observed because there's more people living in some of those places. But that doesn't really explain why you're not seeing quite as many as you used to the places to the west where people have always lived and therefore always spotted them. So a little bit of a conundrum there, but that's what the data suggests now. I don't think there's been any particular argument about why, but that's just an observation about that aspect of severe weather.
Yeah, and that's an interesting comment, John, and also an interesting question, Mike, because I was talking to this state climatologist the other day about tornado frequencies. And if you look at the weak tornadoes in Wisconsin, the number has been going up. And when I asked them that, like, why would that be? And that's when, I learned anyway about the shifting of the tornado alley. But the other thing that they pointed out is that the counting, not only are there more trained observers doing that, but also the radars are getting better. And we'll be able to pick those signatures up more clearer. And so, to your point, Mike, we could see these trends, but it's more than just the trends. Then you have to dig deep into it and try and understand what's causing these trends, because sometimes they align with what we would expect in terms of how the atmosphere behaves. And other times there are subtleties that we have to pull up and account for.
Yeah, the same thing, another indirect way, I guess. I always think the industry that needs to really get this right is property and casualty insurance.
You bet.
Yeah.
Because you've got to underwrite accurately for what the real peril risk is. But of course, there you got the problem that, the value of cars and the value of homes are going up over time. And, in the case of homes, there's maybe more protections that people are taking as there is more severe weather. There are often advantages to investing in a better roofing system. So there could be, more damage because the value is greater, but there could be less damage because the materials are better. And it's really hard to get to the bottom of all that.
Yeah. And you can imagine the insurance industry spent a lot of time, money, and industry making sure they do get to the bottom of that. And that's one place where there's very few global change skeptics. They're trying to make sure that they have hedged their bets in the right way. And very few of those industries now consider this something that's got a serious amount of doubt tied to it, because they just see it, I think, close up more than any of us face to face with claims and whatnot. But it's a very good point. I mean, that any sort of trends that from observations, unless those observations have been taken exactly the same way by exactly the same distribution of observation sites, have to be scrutinized to make sure that you're not overstating or understating what they're telling you in the aggregate.
We're hearing from one of our viewers, Linda McIsaac, that Wisconsin Mutual just raised the deductible on cars to $1,000, which may have to do with frequency of hail and hail.
Yeah.
Interesting.
That's interesting is right. Yeah. So they know, they wouldn't do that. That's not pro customer, really. They don't want to push customers away, but they have to make sure they cover their bottom line. And if there's an increase in hailstorms, something's got to move. So,
I suppose a skeptic would say, an insurance company, they have an interest in higher premiums. And so maybe they want, to tell you, yes, there is systematic change. And that's why we've all got to raise your premiums. But it's still a competitive market at the end of the day.
Yeah. You can't, on the one hand, believe in the power of the market, and on the other hand, say, no, it only works sometimes. I think that's not fair.
So I agree with you. I think people in that industry, more than many other industries, have a pretty sober view about these trends. And
I think so.
They're worried that they're going to continue.
Yeah, I think wasn't there an announcement somewhere in the country? Maybe it's down the south coast of Florida. I don't want to scare anybody, but I heard something along such lines in the spring that there are some places where the insurance rates have gone to such a high level they're almost impossible to pay for the average person, and it has to do with a hurricane threat. But it's somewhere down in that part of the country, but it's gotten pretty bad in some instances. Again, I think reflecting this reality.
Yeah, a lot of state regulators are pretty reluctant to allow big premium increases. You got to get those approved. And so I think there are a lot of places in the country that insurers are beginning to say, we're not even going to write policies here anymore.
Yeah.
Because we're not getting the kind of rate we think we need based on the peril. So certainly some evidence there.
I want to go back to the comment about how great the weather's been. Getting a little down with all this destruction.
Yeah. I mean, someone asks,
right?
Are the trends ultimately good for Wisconsin? Good for Wisconsin agriculture? You know, if Wisconsin was a bit warmer, maybe a little wetter.
I think it would really depend on what industry and what you like to do. So. If you're in the ski industry, then this is not good for your industry, right? Because we're seeing less snowfall. If you enjoy ice fishing, then this isn't going to be very good for you either, because the ice is not only less in terms of its duration, it's thinner as well.
I think it's.
But if you like rivers flooding, that might be okay.
It's inevitable that there'll be winners and losers as the weather shakes out in a slightly altered climate. And my guess is right now that the upper Midwest, especially the Western Great Lakes states, are sort of emerging as a climate island. Our summers are not impossible to bear, even when they get hot and humid for periods. We don't endure it for days on end. And then the winters are getting more mild. So I think if you're in the Southwest, or if you're someplace where it's just getting hotter and water is becoming an issue and whatnot, boy, this is a good place to live. So I think that's true. I think that's an honest question. It's really accurate. But we're a big country, so we have to think about everybody, not just our own region. That's where it gets more complicated.
So tell us, in your field, how do people think about determining the drivers of these trends toward higher temperatures? And, I don't hear people talk about precipitation trends as much. Are those precipitation trends nationwide? Do you think the whole nation is on average seeing a trend of more precipitation?
Probably not everywhere. There's probably places that are seeing increasing drought. But I would say this, that if you take all the places that are still receiving precipitation on a regular basis, so the Northeast United States, the whole East Coast, most of the Central United States and the Pacific Northwest, probably the fraction of events that used to be at the half sigma or the 1 sigma above normal level, that ratio or that frequency is increasing. So the frequency of intense precipitation events, both winter and summer, but more predominantly in the summertime, is increasing. That's something that can be measured, and that's changing. And that's consistent with the notion that as the globe warms up subtly, as it's doing across the whole globe, it isn't just in a local region, the atmosphere is able to hold more water vapor. So there's more available fuel for processing for these precipitation events. And when they really get themselves revved up, they're going to squeeze the sponge a little stronger. The sponge is wetter than it used to be, so you're going to get heavier precipitation events. So that's one thing embedded within the trend that might be the thing to really put one's eye on, is that it's not just that the total amount over the course of the summer is going up, but how it's distributed. It comes in more frequent extreme events. That's really a little bit daunting.
Interesting. So I guess what you're saying is the standard deviation of rainfall for a rainfall event is higher than it used to be,
or at
regions of the country.
At least the number that exceeds a threshold deviation from the norm is now higher than it used to be in a lot of places.
Got it.
Yep.
Okay.
And that creates all the problems, like how do you store that rain data, as well as the damage that it can do.
Yeah.
When you get 3 inches spread over 3 weeks versus 3 inches in an hour and a half, that's going to be very different impact on the environment.
That's right.
You can golf more days if it's compressed into an hour and a half.
There you go. There you go.
I have never golfed a day in my life, so I'm having a hard time understanding that. But
well, I spend all my time.
Productivity, doesn't it?
My golf course time is really low, but my time in the woods, in the vicinity of golf courses is very high, looking for balls and whatnot, usually my own.
All right, let's go to our viewers. So Chuck Weiss did ask us about whether the increase in temperature and rainfall in Wisconsin is better or worse for agriculture specifically. Any thoughts on that?
I'm not an expert in agrometeorology and how the precipitation or temperature trends affect it. I think it certainly seems to me that if you can increase your precipitation, that's going to save the farmer irrigation costs, and that's probably a good thing. And temperature-wise, I don't know how sensitive corn is, and if its sensitivity varies throughout the growing season or not. So that's another question that would have to be approached in some way like that. So, but I think, as I said, I think it's a fair question, and I think that there's probably some benefit to having an increased amount of precipitation over the course of the summer, so long as what you're growing responds to it in a positive way. And maybe that would be something that would, have to be studied by people who really know what they're doing, and then say, hey, maybe if we move a little bit more away from this crop to this one, given these conditions, you'll do better. So probably.
Interesting.
Yeah, we were just spending time out in Western Oregon, and very hot. The high all week long was 103 or so, and dry. And the crop that they were growing was wheat, and so if we really get to that hot weather, drier weather, it would sustain that. Although that's not the direction Wisconsin's going.
Yeah.
As John is saying, I think you would be looking at what kind of either the crop that you would change, or would it be genetically modified in order to deal with the changing temperature and moisture.
I was in Oregon during those 100-degree days the weekend after July 4th.
Oh, yeah.
Took refuge in Bandon Dunes.
Yeah.
That's right.
That event was incredible.
It was not fun. Yeah.
From our original questions, we did mention that Beryl was the earliest Cat 5 hurricane in the Atlantic season just this year. Does that bode ill for the rest of the hurricane season, or is that just, a one-off random event? Any thoughts on that?
Yeah, I'll start. I'm not sure it's a one-off event. I think that there's probably 2 or 3 broad environmental characteristics that determine the nature of the season, the hurricane season in the Atlantic Basin. But one of them is the heat content of the ocean, which is fueled by the intense radiation and the inability to cool off, and the inability to cool off is a function of the increased carbon dioxide fraction in the atmosphere. So the ocean's emitting infrared radiation, but if there's more carbon dioxide in the atmosphere above it, then that carbon dioxide will absorb some fraction of that outgoing radiation that it used to not be able to absorb because it had a lower fraction of carbon dioxide, and then it'll send that radiation back to the ocean. So it effectively puts a thermal blanket on the ocean, even during the wintertime. And so I think the Cat 5 Beryl is a function of oceanic heat content, and to the extent that it is, then that does mean that the ocean is really ready to support the occasional tropical storm that develops. I think, broadly speaking, the tropical atmosphere is somewhat hostile to the development of these storms. But when they do emerge, the thing that keeps them going, like a root system, is the warm ocean water. And so Beryl gives us a little bit of a canary in the coal mine on what's going on with the ocean heat content. It's way, way up there this year. And that can be measured in other ways as well. But to see a manifestation of it like that, it puts a little bit of concern in me. And this is really, 15th of July is really the honest beginning of the hurricane season, is when you really start to have to worry. So it could be interesting.
And then the flip side of that, again, gets back into the subtleties. There was because I thought the same thing, right? The sea surface temperature is going to go up. In fact, if you're below a certain temperature, sea surface temperature, you won't get a hurricane.
26.5 degrees.
26.5, right. But the other thing that goes with it is the dynamics in the atmosphere. And so there was a study that just came out just recently that looked at these Atlantic hurricanes can get seeded by easterly waves that come off of Africa, off the west coast of Africa. And in the atmospheric global warming that we're seeing, those patterns are changing. And so as those patterns change, the ability for the atmosphere to seed the beginning of a hurricane may also be changing. So you end up getting two competing things working against it. But once they get going, I think there's no doubt in my mind you're going to get more of these Cat 4, Cat 5s, because not only is the sea surface temperature warm, that warm is very deep. And so even as you move it up, you're not going to cool it down.
That's the thing. I mean, once one of these storms gets going, it's like a wild animal let out of a cage. It really feeds back on itself. But until and unless that happens, the tropical atmosphere does a pretty good job of keeping these things at a minimum. Because even in an extreme year, you get 25 storms. That's not that many over a 90-day season. So, but the ones that get going pretty much shape the environments in which they form, and especially the strong ones. They can totally alter the environment, make it what they need it to be, to turn into something bad, especially if the ocean's warm.
And then as the damage that happens in those, as we saw with Beryl, is again going back to what is the impact when they actually hit land as well.
Yeah.
And we got some of the residue of Beryl, right? I mean,
we had clouds in the sky that day, a little bit of rain from it. Yeah. Our famous flood in August 2018 was a redirected tropical cyclone. That particular storm had never made hurricane status, but it flooded Texas and then came northward along the Mississippi and gave us the floods that did some damage at Lake Delta and some other places. Once in a while, the remnants of those tropical disturbances can really impact the weather here.
So along those lines, Pam Evans asked, what is the cause of all the rain this season? Is there a particular thing you would point to? She remarks, having a stationary high system south of us might be something that traps a lot of clouds and leads to a lot of precipitation here. Is it that simple, or is it a multitude of things going on? What do you have any thoughts on that?
Yeah, it's usually more than one or two things, but she's got her eye on one of the right things. I mean, if we have a big anticyclonic gyre in the central part of the United States, so flow that's clockwise in the middle troposphere, and at the northern extent of that clockwise flow associated with that disturbance, it's traditionally the case that you can easily create some pretty deep thunderstorms because that environment helps to foster deep convective updrafts. And I think that has been a factor. I mean, if you look around the region, not every place has gotten twice their normal May 1st to July 15th precipitation. Quite a number of places have, but not everywhere. I think northern Minnesota has not. And that's more traditionally the place where boundary waters, blowdowns and whatnot occur from June and July. And that's, I think, been absent comparatively this year. And things have been moved a little further south. So that thing that went through here on Saturday and Sunday was one of those kinds of storms. And it was displaced latitude-wise a little bit than its normal place. So I'd say that it's been a whole bunch of factors, but that one, the anticyclone in the middle part of the troposphere, has certainly been one of them. Yeah.
And when we have that high-pressure system sitting in there and the thunderstorms pop up around it, is that what at one point somebody called that the ring of fire?
The ring of fire on the northern edge. That's right. It's the ring of fire. Yep. And it's aptly named because almost every afternoon you get a flare-up of these really intense thunderstorms, sometimes without much wind, but a lot of thunder and lightning and heavy rain. So that's kind of been our story for July. So,
is there a way we measure intensity of a thunderstorm, or several? Like, what are the metrics you would use?
I guess for me, and then I'm not an expert in that, so it's not one of my fields of particular inquiry, but
Isn't it latitude? Come on.
Well, yeah, but winter storms, as you pointed out, or you tried to point out at the beginning, you stretched the truth a little bit there, Mike. I'm not really a summertime convective weather person, but I like it. I just don't understand it. But I think now I've gotten myself off my point.
Measure like the electricity, or just
you can measure the polarity of the strike, the frequency of lightning strikes. You can even measure the cloud to cloud lightning strikes, the ones that don't hit the ground. Triangulate to find where they are. And that gives you an indication of maybe where the ice is concentrated in a storm, and then radar, whether the precipitation reaches the ground or not. You can cut through a storm with the radar profiles and see where the heaviest pieces of ice might be, for instance. So I think all told, and then just precipitation at the ground, all told, there's probably a whole bunch of ways in which the intensity of these things can be measured. And then the aerial extent, how far do they extend, and so on.
Yeah, I think they would be more typically categorized by the amount of the size of the hail that would be really categorized that. Although, as John was saying earlier, the wind speed, whether it's a straight line winds that are just going to blow forests over, or things like that, it tend to how they get classified in terms of the severity.
Yeah.
Have we made a lot of improvements? I assume we have, in our ability to measure these atmospheric conditions at a lot of different points geographically. I mean, what do we do? I mean, you were noting, we've got, there's the storm chaser industry, which probably didn't exist 40 years ago. There's kind of more eyeballs on this kind of stuff. It's gotten a lot of attention. But do we systematically put in place measurement systems beyond temperature and rainfall?
Yeah, I mean, I think the big ones would be radars, but of course, radars are really looking at precipitation and storms. They're getting very accurate as well. And then, of course, satellites. We're using satellites now to really fill in the spaces of where observation sites may be distributed across the land. And that really helps in terms of identifying where storms are, but also the clear sky conditions in terms of the atmosphere, temperature, moisture, and even winds are now being measured from satellites. And the other thing I'll point out, because I think it's so important when we talk about radars, is that when you're in the U.S. and you want to know if rain is coming or not, you just fire up your phone and look. If you're in Europe, you can't do that unless you pay for it. And so these observation systems are also freely available to the public or industries to use in terms of how they need to use that data. And that's also a really big, important part, I think, of what's been going on in terms of advancements.
Yeah, I think that's an excellent point, Steve. The fact that this kind of stuff is now routinely available and well understood by a huge fraction of the population, that's a real revolution, and it should not be taken for granted. And that data is actually used. It's assimilated. That's a complicated word for digested and then transformed into a form that can be used in these numerical forecast models, which continuously get better and better and better at forecasting these very storms within, in the 6 to 12, sometimes 24-hour range. I mean, it's rained a lot here this spring, but there have been very few days where there was a forecast for no rain where something substantial occurred. Very few. And I think it's easy to be myopic about that in the sense that 20 or 30 years ago, those kinds of forecast errors were routine. We baked them into the cake about how we approached our summertime, whether it was for work or leisure. Now we don't even have to do that. It's almost like the revolution of you don't need to consult a map before you get on the road to go somewhere. You just plug it into your GPS. It's almost like that.
It's like my stock market forecasts.
Just like it. Except we're not making that freely available.
Well, right.
So,
which may be a good thing, John.
Maybe it is. Maybe it is. I guess I don't know.
that was a joke. Yeah.
Yeah.
I'm exhibiting forgetfulness there. So you made a point about measuring the accuracy of forecasts. That's so. Has that been quantified in research? Like, can we show that weather forecasts that have been made in a particular place just gotten more and more accurate over time?
Yeah, there's
and
ways.
How far out? Like I go on my weather app, I get 10 days, 2 weeks of forecast. I'm sure you can go back and along some metrics of temperature and precipitation measure accuracy.
Yeah, it's a really good question. I mean, there's a whole bunch of kind of old-fashioned metrics that were invented in the 70s and 80s for the application to this problem as numerical weather prediction really started to, to gain ascendancy. What are they called? Error correlation statistics or something like that. There's a word I can't think of off the top of my head, but there's been a steady improvement in the 1, 3, 5 day forecasts by all of the major national weather services, both ours here in the European Center for Medium Range Forecasting, the Japanese Forecast Agency, and all of them. So they now at anomaly correlations, that's what it is. You correlate anomalies that show up in the flow based on your forecast. Did they occur in the forecast in the same place that they occurred in the reality? Because we have observations coming in all the time. And the anomaly correlation coefficient for the mid-tropospheric flow around the globe is something at like the 88% correlation. So we're at really high levels of accuracy at 5 days. more so in the wintertime than in the summertime. Summertime storms have shorter lifetimes and therefore can develop and die in a very short time, sometimes within the forecast window. And that accounts for some of them popping up out of nowhere. But doesn't happen very much in the cold season. And that's a real revolution. I mean, when we think about it, all three of us right now, we all were born at a time where there was no such thing as a 2-day forecast. Absolutely no such thing as it. And now a 2-day forecast is about as easy as flipping a coin. And I don't mean about accuracy. I mean physically doing it. And so you can get to 7 and 10 days now with remarkable accuracy, especially if you lower the threshold to just say, I'm satisfied if you accurately paint the complexion of that 10th day. If you do that accurately, I can take that. And we do that all the time now. It's remarkable.
Throwing us under the bus on birth year, Ackerman. What do you think about that? How does he know all this?
Well, I was going to support it by saying when I came here as a young man in the late 80s, I would look at a 2-day forecast, but nothing beyond that. Now routine, a 4 or 5 day forecast, see what it's going to look like out. I'm not afraid to do that anymore.
I know. I get a kick out of it. People looking at their phones and going, boy, it said Wednesday was going to be this. And I just tell them, look, keep score at home or quit complaining, So you got to keep score.
Yeah.
Honestly.
Well, that's good to know. So a question from Steve Malpezzi, one of my I don't know. Do you know Steve? He's a
I don't
former professor at the business school, lives in Boston now. Anyway, Steve, also an alum. He notes, maybe you're aware of this, a few years ago, NOAA stated that we had higher confidence of a relationship between climate change and extreme heat, extreme cold, and rainfall. I guess that would be the climate change, but and then confidence in the link between climate change and convective storms and tornadoes was lower. So in other words, I guess maybe what Steve's getting at is extreme heat, extreme cold, rainfall maybe are changing systematically, and the climate is in fact different, but we don't see the same uptick in convective storms and tornadoes.
I think I'd interpret the question a little differently than that.
Okay. He thinks there's more attribution lately, but go ahead, rephrase that.
I think it might be this, that the first few, extreme heat, extreme cold, and rainfall carried as they tend to be by mid-latitude storms in the cold season or in the cool season, not so much in the summertime. Those are easier to fit into the climate problem than I think individual convective storms, which, as I said a minute ago, can grow and die within an hour or two. The ones that last long and do real damage are 12 to 24 hours long. So they're much more substantial storms, both in what they do and how long they live. But the vast majority of convective storms have very short life cycles, so that it's difficult even to make accurate point-to-point forecasts about where they're going to develop in a numerical weather forecast model 3 to 5 days out. You can say that the risk is there for 3 to 5 days out over location, and then you resort to vigilance with the radar and the 1 to 2 day forecast. But for a climate model to try and pinpoint that and to actually start to accrue statistics that suggest it's doing a good job at making that kind of a pinpoint forecast of small-scale, short-lived storms is difficult. And I think the attribution follows from that difficulty. I don't know, Steve, whether or not there's been updates in this attribution science. I think that I'll say this. I think I know you're right. I just don't know what the current state of the art is on that. I suspect it's probably improved, but not as fast as attribution for other of the signals that you're discussing with respect to climate change.
Yeah, and I agree, and I think you're right. The attribution's changing, and I think part of that is when we talk about thunderstorms in particular. If you want to get a thunderstorm, you need warm, moist atmosphere, and we know what that stability needs to be. And as global warming's occurring, we're getting that. But the other thing that's a little bit more subtle is we also need atmospheric dynamics. We need the jet stream in the right place. And it's that attribution of where is the jet stream going to be as we get to global warming, and how does it correlate or line up with those areas where the temperature structure and the moisture structure is good enough that we would get a thunderstorm to develop.
Yeah, that's an excellent.
That's subtle.
It's very subtle, and it's not something that the climate a climate type model is going to try to make a forecast up on a given day, and that's really what it comes down to. Yeah, that's exactly right.
Lou Blazik wonders if you can comment on the warming of the oceans near the Australia Barrier Reef.
I don't know anything about that, unfortunately.
The only thing I'm aware of is that it is warming, and that's why you're getting the bleaching of the coral that's down there. What the trend is, I'm not sure. I would imagine there's nothing that has changed the warming trend. I think we would have been seeing that in the news a lot if that were the case. If for some reason the global circulation of the Southern Atlantic, Southern Pacific were to change to bring more cooler water in there. I can't imagine that unless Antarctica melted or something.
Yeah, and or the other. If there's warmer water that's continuing to reside there, my first thought is maybe there's a trend in cloudiness in that part of the ocean that's decreasing cloudiness, and that probably means more insulation and warms the water up and causes the bleaching. But I don't know if that's what people who study it have found. I don't know the answer.
Question from Nazos Lazaridis. Does El Nino or La Nina affect the hurricanes in the Atlantic or vice versa?
Yeah, it's really, I think it's a transitive relationship between El Nino, La Nina, and the Atlantic hurricane season. So that La Nina, El Nino has an impact on the hurricane season, and the hurricane season has no impact on that because the basin is unaffected. The Pacific basin is unaffected by Atlantic hurricanes. So that's a good question. The El Nino often erodes a little bit in the spring. When it lasts into the summer, I guess it's bad news for Atlantic hurricanes because it tends to keep an unusually high vertical wind shear in the vicinity of the eastern part of the Atlantic basin and the western part of the Atlantic basin. And vertical wind shear tilts tropical storms over and really doesn't encourage their development or their sustenance. And in La Nina years, it's just the opposite. They may find a much more conducive vertical shear environment during a really robust La Nina where the shear has been reduced as a consequence of tropical convection behaving itself and being more towards the maritime continent in the Western Pacific.
Sarah Sekeli wonders, does the Sahara dust have an impact on hurricanes?
It does.
Tell us a bit about the Sahara dust, Steve, and then how this happens.
So Sahara dust the Sahara Desert, any big desert is going to generate dust in the atmosphere. And then if you have a weather system move through that's not precipitating, it'll kick up that sand and that dust, and it'll generate a really big dust storm. I happened to be in Saudi Arabia once. We were studying the Indian monsoon when a dust storm hit. And we had a bunch of equipment out there that we need to secure and get indoors. And I'll tell you, it was not pleasant. It was like somebody was taking handfuls of sand and throwing it at you. I mean, it was just miserable. And as much as we tried to bribe the taxi guy to help us, he just wouldn't get out of his cab. But yeah, so those dust storms do come off. They can either go towards India, or if they come off of Saudi Arabia, or if they come off of Africa, they can move out into the Atlantic Ocean. And generally, that's going to be really dry type of air because it's coming off of Africa. And it might have dust associated with it or no dust even in some situations.
Going back to something we talked about earlier, before we went live, just, when you show slides that compare how things were in 1950 to today, Norman Arndt wonders, why is 1950, the right comparison point? And I know there are many others that we could choose from, but maybe you could just comment on why 1950, but also what would this look like if we went to 1900 or 1850 or 1920? Pick your time.
I think it's a good question on a lot of levels. First, the National Climate Data Center uses a 30-year average that goes back from the beginning of the current decade. So I think currently we're comparing everything officially when it's put out by the U.S. government or something from the Climate Center from the 1990 to 2020 average. Is that right, Steve?
Yeah.
20. Yeah, and so this one here is just because we have the data back to 1950. I think this trend of being warmer and being wetter gets worse if you use an older and older date. So, I mean, it would sound less scary if we used the 1990 to 2020 average and compared, that to the prior to 1950 or something. So I think it actually makes the signal worse to go back to 1950.
And I think as the questions that we're looking at, well, there's two things, as John's pointing out. One is you want to drive it back, your time series back in time, to really study the phenomena that you want to look at. And two, you need to have accurate measurements going back that far. So going back to 1950, we have a good confident set of accurate temperature and moisture measurements. The reason why we're going back to 1950, or we would like to go back even further, is we're looking at what is the what's the impact of people on the climate? How are we changing the atmosphere? And again, part of that is really better represented from 1950 on in terms of carbon dioxide in the atmosphere.
Yeah.
And going back further isn't easy because you would say we don't have as reliable of information.
Not as dense a network. I would say that those who were making observations in 1900 were probably doing it just as high, at such a high level as is the case today, but there just weren't as many. And so the density of your observational network is reduced.
Yeah. Okay. Terry Quinn asks, is the Gulf Stream being affected lately, and what is the potential impact of that? I'm sure it's being affected, but
that's a really good question. And there is studies suggesting, and as we go through global warming, as we're losing the ice cap on the northern hemisphere, that will change the flow of the Gulf Stream. And that'll impact weather, particularly in Europe. So it's not so much of how it runs up, as I understand it, how it runs up the East Coast, but once it gets beyond Maine, how does it go? Does it go to Labrador or does it go someplace else? And part of that is associated with the sea ice in Greenland, the ice on Greenland melting and then changing that flow pattern.
Yeah, and I think that's a really good point. And there's something called the Atlantic meridional overturning circulation. So Atlantic, because it's the Atlantic, meridional means north and south, and overturning, the water is going from the top to the bottom. And as Steve pointed out, up near the Labrador Sea, in the wintertime, that water is chilled remarkably by the cold air, and it forces it to get more dense, and it sinks. Storms evaporate water off it, leave it salty. That gets it more dense. If any of those things kind of get perturbed, that's going to change that pumping in the North Atlantic, and that could very well change the Gulf Stream. So it's not that the Gulf Stream will do that in a transitive way. It'll respond to that change, I think, on the bigger scale.
Yeah.
Great. Well, I don't have any other audience questions in the queue tonight. So I think a great way to close, I know both of you think, we are facing some systemic changes to climate that are driven by man-made actions. And I just would ask you, if I'm a skeptic and I'm thinking, look, we've had these swings in climate in the past and earlier centuries, this and that. What would you say to me if I'm skeptical of your point of view that these are man-made factors that are driving these changes that we see in climate? I think you've shown us that there are changes over time. Give me your interpretation, and why should I believe it?
I think an important thing from my point of view is that these changes that we're seeing are physically consistent. So it's not just about, do we see the temperatures in Wisconsin going up? The answer is yes, we do. And as a consequence of that, we're seeing lake ice go down. And so if you don't have those two things in hand, if you can't explain, you can't explain one area or go against one data set and dismiss another data set. And so you got to look at how those data sets and multiple data sets trend, and what's the physics behind those trends, and is all of that consistent?
Yeah, I very much agree with that. I think cherry picking is easy when you're in it. You're in a science or any kind of inquiry that's advancing incrementally with new knowledge and new experiments and new observations. Anybody can cherry pick. What's really difficult to do is argue against the systematic cohesion of all of the different observations and the theories that explain the predictions. And the other thing is, when I first got here 30 years ago, I would say this to any skeptics, and they may agree with me, that it was hard really to see in the day-to-day weather 30 years ago how the climate was encroaching on your lifestyle and on aspects of your life. I think that is less blurry than it used to be. I think that it's really hard to endure this particular May 1st through July 15th and not wonder, is there something about these dice that is a little bit more loaded than it used to be in 1994? The same thing in the wintertime. Why doesn't it snow here anymore? And if you listen to me, I talk about how cold it is over the Northern Hemisphere. It's getting systematically warmer. And there's ways that absolutely fundamental measurements show that. You can't really any longer disregard the evidence of your own senses. And 30 years ago, you could, because it wasn't so manifest in the day-to-day weather. I think that it is now. And I think that should be, I guess I would encourage people to trust their own senses, and comparing what they observe today to what they remember from other times, just wonder whether or not it's actually true that what we are coming to conclude, not believe, we're concluding it based on observations and theory, being consistent with each other, that there really is something up. And we should direct our energies towards solving the problem. And we want everybody's voice in that. Business people, skeptics, scientists, everybody. That's what this great country can do.
Well, that's a great way to wrap it up. I do think, people have different hypotheses about, I think the data speak for themselves. I think the interpretation or the underlying drivers for some people are unclear. And of course, not everybody knows the physics. And so, it's really interesting. I think there are certain areas of science where, if you go to the CDC museum, and you look at all the advances that have been made in curing different diseases, it's incredible, and it's hard to deny the progress through science. But there are other disciplines where, that doesn't happen quite as tangibly for people, and it's harder to understand. But well, I just want to say I really appreciate having the two of you take time out of your Tuesday evening, join us tonight, answer audience questions, give us great perspective on things, and have a little fun along the way. There's nothing wrong with that. So
if it weren't fun, Mike, I don't think John and I would do it.
No. Thanks for
Probably not you either.
Yeah, right.
Yeah.
There's a real pleasure. Thanks.
Next time we do an alumni event live stream like this, we'll have a hosted bar. How about that?
That sounds great.
All right. Well, thank you for joining us tonight, and thanks to our audience for being here, joining the Weather Guys. We will be back again in August with another timely and important topic to be determined. But thanks for joining us this evening, and on Wisconsin.
In 1848, just 2 months after the creation of our beloved state, a great university was born, the University of Wisconsin, to serve, educate, and benefit people from every corner of Wisconsin and beyond. And for 175 years, we have pushed forward, energizing dreams and igniting innovation. With educational opportunities that create promise and research that improves lives, UW-Madison is a place where an idea can change the world. And as we look forward, we also look back to stand up for what's right, build common bonds, and a better future. When combined with inspired goofiness and Badger spirit, there's an inspirational and unconventional vibe that's all Madison. It's more than just fun and games, though. At the UW, we go from brainstorms to breakthroughs, from today's students to tomorrow's leaders. This is where an idea can change the world, the whole world, a corner of the world, my world, our world. UW-Madison's profound eurekas and personal ahas transform us all and serve the greater good. As proud Badgers, we celebrate the last 175 years and the next as the UW charges forward. On Wisconsin.